The digital systems we rely on every day are built on a foundation that is surprisingly fragile. Hidden within the core code are microscopic flaws, invisible stress points that have remained under pressure for decades. Anthropic recently tested a new model, known internally as Claude Mythos, against these foundational systems. Within weeks, Mythos identified a critical bug in OpenBSD, an operating system renowned for its security, that had remained undetected for 27 years. It then scanned FFmpeg, the engine that processes video for nearly the entire internet. It found a vulnerability that had survived 16 years and successfully evaded over 5 million automated security tests. These discoveries suggest that traditional security measures, both human and automated, are unable to detect specific, catastrophic flaws that have been part of our software infrastructure for decades. Curious, the irony of these discoveries is that Anthropic never actually trained Mythos to find security flaws or act as a hacker. They simply trained the model to be an expert at writing code. But the logic of software is dual use. Understanding exactly how to build a complex system grants the specific knowledge required to dismantle it. It is like training someone to be the world's most skilled locksmith. You don't have to teach them how to break into a building because their understanding of the locks makes the process intuitive. This skill allows the AI to autonomously identify harmless bugs and link those isolated errors into a single coordinated attack, bypassing firewalls. For human hackers, chaining vulnerabilities is a manual, slow process. Mythos performs these operations instantly, striking dozens of targets simultaneously. By focusing on coding assistance, Anthropic created a tool that can systematically identify and exploit the flaws guarding the internet's most critical software. The benchmark data confirms that this is a generational shift in what artificial intelligence can do. On the SWE bench, measuring an AI's ability to solve real-world software engineering problems, Opus soared 80.8%. Mythos climbed to 93.9%. When tested specifically on cybersecurity exploits, the gap is wider. Opus scored 66.6%, while Mythos reached 83.1%. From a commercial standpoint, releasing this model immediately would likely lead to massive financial gain and give Anthropic total dominance over the AI industry. However, a public launch would also provide every malicious actor on Earth with a tool more capable of finding exploits than most professional security teams. Anthropic cannot keep this a secret forever. AI capabilities scale at an exponential rate, meaning smaller open-source models will likely reach this level of hacking proficiency within the next year or two. This left Anthropic in a difficult position. They're holding a tool capable of compromising global software infrastructure, one they cannot safely release, cannot keep secret, and cannot uninvent. Instead of choosing between a dangerous public release or total secrecy, Anthropic launched Project Glasswing. They decided to give early, exclusive access to the companies that maintain the internet's core infrastructure, including Apple, Google, AWS, and Microsoft. These partners are now using Mythos to scan their own codebases and silently patch zero-day vulnerabilities, flaws that were previously unknown, before they can be discovered by attackers. This strategy attempts to change the traditional math of cybersecurity, giving people defending the network a significant head start before these capabilities become widely available. This creates a form of trickle-down security. When a bug is patched in a foundational system, like an operating system or a web framework, that protection cascades down to secure the browsers and apps on your phone or laptop. This also shifts the economic burden of security. Small businesses that cannot afford elite security audits are now protected by an automated AI defense that was originally deployed to secure global infrastructure. Anthropic's approach is now being viewed as a potential standard for how to manage a technological breakthrough that has both high utility and high risk. The question now is whether other labs like OpenAI or Meta will follow this defensive playbook as their models become more capable, or if the race for market share will lead to more direct public releases. While the competition to build more powerful AI is accelerating, this event suggests the industry has the capacity to secure critical infrastructure before the vulnerabilities it discovers are exploited at scale.